The strangest objects in the universe. What if I told you the cosmos harbored secrets so strange they could rewrite everything we thought we knew about reality? From dazzling beacons of light outshining entire galaxies to mysterious entities seemingly ripped out of science fiction, the universe is a treasure trove of the inexplicable and the awe-inspiring. So buckle up for a wild ride as we uncover the strangest objects in space, a journey where the truth is stranger than fiction. Let's begin with quasars, the celestial light bulbs of the universe. Imagine a single object so luminous that it outshines the combined light of billions upon billions of stars. That's a quasar, a beacon of energy that sits at the heart of a distant galaxy. So what exactly powers this cosmic brilliance? At the center of every quasar lies a supermassive black hole, millions or even billions of times the mass of our sun. As matter spirals toward the black hole, it forms a swirling disk called an accretion disk. This disk heats up to unimaginable temperatures as the material accelerates, releasing torrents of light and energy. The result is the quasar's iconic glow, which can be seen across billions of light years. In fact, quasars are so bright that they help astronomers map the distant early universe. They're like cosmic lighthouses, offering clues about how galaxies and black holes evolved in the first billions of years after the Big Bang. But it's not just their brightness that makes them fascinating. Their power is equally chaotic. Quasars blast radiation and winds, shaping the star formation around them and carving paths through the galaxies they inhabit. Quasars teach us what happens when impossibly large forces collide, giving birth to some of the brightest and most energetic objects in the cosmos. As stunning reminders of the universe's scale and power, they are unmatched. From unfathomable light to incomprehensible force, we turn next to magnetars, the universe's magnetic monsters. Picture this, a magnet so powerful that if one were to appear within 1,000 kilometers of Earth, it could wipe out all electronics on the planet, and even affect the molecular structure of your body. That's the terrifying potential of a magnetar. Magnetars are a rare type of neutron star, born from the collapse of massive stars that have reached the end of their lives. What makes them unique is their magnetic field, trillions of times stronger than Earth's, and billions of times stronger than the most powerful magnets we can create. But why are magnetars so magnetic? That's a question scientists are still working to answer. One theory is that their magnetic field arises during the violent and chaotic process of stellar collapse. As the star's core shrinks to an incredibly dense neutron star, the angular momentum and magnetic field intensify to unimaginable levels. These extreme fields don't just sit quietly, they wreak havoc. Sometimes magnetars release magnetic energy in the form of bursts or flares that can be detected across the galaxy. One particularly infamous flare in 2004 came from a magnetar about 50,000 light-years away, and was so strong that it disrupted satellites and communication systems on Earth. And that's from halfway across the Milky Way. Magnetars are short-lived compared to other cosmic objects, their magnetic forces decaying after a few tens of thousands of years. Still, during their brief existence, they remind us just how strange and dangerous the universe can be. Now imagine a planet drifting all alone in the cold, dark void of deep space. No star to orbit, no sunlight to bask in. These are rogue planets, cosmic drifters that roam the galaxy untethered, silent and mysterious. So how do planets like these come to be? In the chaotic early years of star system formation, collisions and gravitational forces often eject planets from their homes. Once thrown out, these rogues wander through the galaxy without any celestial guide. What makes rogue planets particularly fascinating is the speculation around what conditions might exist on them. Despite the absence of sunlight, some scientists theorize that rogue planets with thick atmospheres could trap residual heat from their formation or even sustain subsurface oceans. Could life somehow exist in such extreme conditions, hidden beneath layers of protective ice? It's a thrilling possibility that keeps astrobiologists awake at night. But rogue planets aren't just a curiosity. They're far more common than you might think. Astronomers estimate there could be billions of rogue planets floating through our galaxy, each a lonely traveler with its own untold story. Rogue planets challenge our perception of what is necessary to sustain a planetary system. They're enigmatic and eerie, confronting us with one of the universe's most poetic images, a world adrift in cosmic solitude. If we think about black holes as cosmic vacuums, endlessly consuming everything unfortunate enough to cross their event horizon, what if there were objects that did the exact opposite? Enter white holes, hypothetical constructs that flip the very concept of a black hole on its head. White holes are theoretical objects that spew matter and energy outward, rather than pulling it in. According to Einstein's equations, a white hole could exist as a kind of reverse black hole, a place where nothing can enter, but everything is ejected. So far, no white hole has been observed, and they are entirely speculative. But their mere idea sparks tantalizing questions. Could they be linked to black holes via some sort of wormhole or bridge through space-time? Are they evidence of parallel universes or alternate realities? Some researchers have wondered if white holes play a role in the birth of new universes. Could a white hole's outpouring of matter trigger the start of something like the Big Bang? It's an idea that boggles the mind, but fits neatly into the framework of theoretical cosmology. Whether they're real or just a mathematical quirk, white holes remind us of the wild possibilities lurking in the corners of physics. They push the boundaries of what we think space-time might be capable of and open a door to realms we can only dream of exploring. Let's turn from theoretical to explosive with O-type stars, the rare, short-lived titans of the cosmos. These stars are the big, flashy rock stars of the universe, living fast and dying young. They burn with a brilliant blue light and are dozens of times larger than our sun, but this extraordinary brightness comes at a cost. O-type stars burn through their nuclear fuel at a breathtaking rate, lasting only a few million years, a blink of an eye in cosmic terms. Their immense heat and energy cause powerful stellar winds that blow material away at incredible speeds, influencing their surroundings. These winds can shape massive regions of gas and dust, kickstarting the formation of new stars. But the end of an O-type star's life is where the real fireworks begin. When they run out of fuel, these stars don't fade away gently. Instead, they explode in supernovas so powerful they briefly outshine their entire galaxy. Though rare, O-type stars are critical to the chemical richness of the universe. Elements they create during their lives and destroy in their deaths can end up in planets like Earth, or even in the bodies of living beings. In a way, O-type stars are the ultimate creators and destroyers, leaving behind legacies written in stardust. The universe is an endless tapestry of wonders, but few objects stand out for their sheer strangeness, like quasars, magnetars, rogue planets, white holes, and O-type stars. Each of these phenomena challenges us to stretch our imagination and rethink what's possible in the vastness of space. These bizarre objects remind us that, despite our scientific advances, there's so much we don't know about the cosmos. They're puzzles waiting to be solved, treasures waiting to be discovered, and stories waiting to be written. As we peer deeper into space, our questions grow, and so does our wonder. The universe is a strange place, but it's in that strangeness that we find its greatest beauty. So keep looking up. The next mystery might be stranger than anything we've uncovered thus far.